Okay, we're going to talk about matrices and using inverse matrices to solve systems when we have two equations, two lines, things like that. But before we get to inverse of matrices, I want to talk about just inverse operations. So if I solve this following equation for f, the least connected to the f right now is the 5/9, and so what we've learned to do is multiply by the reciprocal, 9/5, and so if you do that, 9/5 times c, the 9/5 cancels out with the 5/9, and you're just left with f minus 32. And so the 5/9 and 9/5 cancels out to 1. And then if you add 32, you get f. So what inverse operations? Inverse of multiplying by 5/9 was multiplying by 9/5. Or, in other words, you could also divide by 5/9. That's the same thing. Inverse of that subtracted 32 was an added 32. Things that undo each other. And so matrices have undoing things as well. The biggest thing is that we have, this is a multiplicative inverse. When we multiply 5/9 times 9/5, we get 1. And when we get a subtracted 32, add 32, negative 32 plus 32 equals 0, the additive inverse. And we have 5/9 times 9/5. That equals 1. And that's the multiplicative inverse. Now, all of this to say, 0 is the additive identity is what I meant to say. 32 is the additive inverse of negative 32. Identity. And the multiplicative identity. And so that's what we're always trying to get it back to. So, identity matrices. What happens if you multiply by an inverse matrix? You get the identity matrix, just like you get 1 when you multiply by reciprocals. A 2x2 identity matrix and a 3x3. Notice that the 1s are on the diagonals. And we're not going to take the time to demonstrate this, but if any matrix multiplied by the identity matrix is itself, we'll call this matrix I, the identity matrix, and this could be identity matrix as well, just that A times I equals A, or I times A equals A. The identity matrix does that. So, we have a matrix equation. A times x equals b. We don't know what x is, but we do know what a and b are. In algebra, we would divide both sides by a, but there is no division in matrices. And so what we do instead is we multiply by the inverse. And so I'm going to do a inverse times a times x. A inverse times b. Notice the side that I did it on. When I multiply a inverse times a, that's like 5/9 times 9/5. That gives me the identity matrix. And the identity matrix, we'll just multiply it by 1 in a sense, and so x, the matrix x, is equal to whatever the inverse of a is times the matrix of b. And so it's essential that we can find the inverse of a matrix, just like in order to cancel out the 5/9, we multiply by 9/5. It's multiplicative inverse. So, inverses. Notice that the inverse, we use a to the negative 1 power. That's the notation. A to the negative 1. it's got the scalar constant, scalar multiple out front. 1 divided by the determinant of whatever it is. And then notice that A and D swap spots. A and D. And then B and C stay in the same spot, but they become negative. So, let's try it. This is going to be 1 divided by the determinant of D times, we'll say B because that's what we're dealing with, times flip-flop the -3 and the 5. And make the 2 positive and make the 8 negative. Opposite of these diagonals. So the determinant of B, that's what we need to figure out next. Determinant of B is 5 times -3. We multiply, check out the last video if you didn't see this one. 5 times -3 minus 8 times -2. So -15 plus 16 equals 1. And so this is actually pretty, but otherwise we'd have to do 1 divided by 1 times -3, 2, -8, and 5. But instead, this going in there is just what we had before, because 1 times all that. Sometimes inverses get ugly as far as with fractions, and so just be careful. Just be patient with it. Maybe if this was 17, you'd have to multiply each one of these by 1/17 to just give you the common denominator of 17. Thing to keep in mind, if your determinant is 0, you can't have an inverse matrix. And so that's what we were sort of talking about in the last one. If your determinant is 0, you'd have to divide by 0 here, and that's impossible. Can't divide by 0. Inverse matrices on a calculator. Let's get our same 5, -2, 8, -3. So let's go to our matrix. Five, -2, 8, -3. It's really quite simple. So what we did was matrix, and we went over to edit, and we changed our matrix A. Choose our matrix A, and then right above a matrix it has to the -1 power, x to the -1. And so we get -3, 2, -8, 5. So we're good to go. That is our inverse matrix. And we're going to use this to solve a system here in a little bit. So inverses matrices on the calculator, whatever A is, to the -1st power. Remember to use the matrix button, and you can add any of your needed things there. So, before we discover where this came from, again remember, I want to take the inverse of this one, and so AX equals B, A inverse, multiply the inverse, and we'll get it. So because this cancels out. So (3, -2, -7, 5 to the -1. Notice that we're putting it on the same side here. And so I'm going to grab matrix B, which is, or matrix A, 2 by 2, 3, -2, -7, 5. Matrix B, -2, 4, 3, -1. And I'm going to do matrix A, inverse times matrix B. So if we multiply this matrix times this matrix, we get this matrix. So our answer here, if we multiply our answer, if we multiply matrix A times our answer that we got, we get our original answer to that. So that's how an inverse matrix works. You get back to where you started from. Notice that the order was important. So now let's use it to solve a system, really to get to the heart of it. First thing you want to do is set up your matrix equation. And so we have a matrix, -2, 5, 3, and 1. This matrix is just all the coefficients. You have an x column and a y column. And what happens when you multiply matrices, remember that you multiply the row times the column. -2 times x plus 3 times y equals and 5 times x plus 1 times y equals 19. So solve your matrix equation. You essentially have an AX equals B. So again, we need A inverse of A inverse times B. And so we have x equals A inverse times B. And so I'm going to use matrix A, -2, 3, 5, and 1. And matrix B is 2 by 1, a -11 and a 19. And so now what we want to do is inverse A. So matrix A, you can take the inverse of it times matrix B. And here we go, get 4, -1. And so step 3 is interpret your answer. So that means that this was equal to x, which was this matrix, xy. So our solution is 4, -1, as far as had we used substitution, had we used elimination. 14. Notice this would have been so much faster just to solve with substitution perhaps or elimination, but this will definitely be a time saver using matrices. And so set up our 2, -1y, 2z. Pardon my 2's, they kind of look like z's. -3, 2, 4 times xyz. Notice that each one of these would get multiplied by each one of these. And then we have our constant over here. All our stuff on the other side of the equal sign. So keep in mind, This is A times X equals B. And so again, the exact same, if you multiply both sides by A inverse, just like we did up here, I'm just skipping that middle step. Call this A, call this B. Let's stick it in to our calculator and see what we can find. Matrix A, we're going to edit to 3 by 3. You always want to double check what you're typing in. Matrix B, my matrix B is a 3 by 1 now. Negative 21, 25, and 6. So, I'm actually going to just hit second enter because it's doing what I want it to do and I changed the input. So we got X was equal to negative 4, 5, and negative 4. And so what we can say is negative 4, 5, and negative 4 is our solution. Now, sometimes you have story problems, and you have to write this system of equations. So, take for example, at a video store, cost of 3 DVDs, 2 video games, and 4 VHS movies. So let's call 3 DVDs, VHS, games, and DVDs, just to make it easier. We'll use our... So, 3 DVDs plus 2 video games plus 4 VHS movies, $130. 2 DVDs, 1 game, and 5 VHS movies is $105. 3 DVDs, 3 games, 3 VHS movies is $135. Now some of you would insist on just guessing and checking your way through this problem. That's perfectly fine if that's what you want to do. I'm going to set up a matrix. And we've got all our constants, 3, 2, 4, 2, 1, 5, 3, 3, 3. And our variable matrix, D, G, and V. D, G, V. Notice what happens again, remembering that we do, if we were to actually multiply this out, we'd get 3 times D plus 2 times G plus 4 times V. We'd get the first row. Or you could do it with any one of those. So again, A times some matrix X equals B. So X equals, if you take the A inverse and A inverse, alright, let's see if we can do this. Matrix A. Matrix B is a 3 by 1, 130, 105, 135. And matrix A inverse matrix B, 20, 15, 10. So what does that mean? Find the cost of each item. DVDs, $20 each. $15 per video game. And $10 per VHS. And there you have it. So, half of the battle on the story problem is setting it up. Good luck.